All right, IBAISL1. Today we're starting chapter 9, which is we're starting out talking about exponents and exponential properties. So the first thing I thought I'd talk about is what even is an exponent. This part of the number, this big part, is called the base of the exponent. And then the top up here is called the exponent or index. Now, what does it mean to raise 2 to the 4th power? It's not 2 times 4. It's 2 times 2 times 2 times 2. So you're multiplying 2 with itself 4 times. So that would be 16 if you were to simplify this. So 2 to the 4th power is 16. Now, one of the goals of today is for you guys to be able to work with the powers of exponents and the laws of those exponents, like when you do certain things to the bases and to the exponents. If you ever forget how these rules work, I always just think of expanding these. So, if you are to expand x squared and x to the 6th, the x squared part is just x times x. And then x to the 6th is 6 more x's. So x squared is just those 2 x's, and then x to the 6th is 6 x's. And now if you count up how many you have for grand total, you have 8 x's. So when you simplify x to the 6th, you go x to the 2 plus 6, which is x to the 8th. So when you are multiplying two things together that have the same base, you add their exponents. So the rule for this is if you multiply a to the m times a to the n, you get a to the m plus n. Now, if you were to divide two exponents or two things that have the same base, what you would do with their exponents, I just expand it once again, that you would have 6 x's on top and then 2 x's on the bottom. Then if you look at this, there's 2 sets of x's that cancel each other out. So those 2 go away, leaving us with a grand total of 4 x's. So what actually happens here is you take x to the 6th and you subtract the bottom exponent, which is x to the 4th. So if you have a to the m over a to the n, this is a to the m minus n. You subtract the top from, or subtract the bottom from the top. Now, if you have a power of 0, if you think of, if you use the rule that we just established about dividing the exponents, that would mean that this would be x to the 2 take away 2, which is x to the 0. Now, if you think about expanding these two, this is xx over xx, which is like these cancel out and these cancel out, leaving us with a big 1. So what this tells us is that anything to the 0 power is 1. So that's the rule, that if you raise a to the 0 power, you get 1. Negative exponents. So if I use that division rule, this would be x to the top minus bottom. So this is x to the negative 2. Now, what is x to the negative 2? Well, let's take an expanded version of this. So we do x times x times x all over x, 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 so the 5 of them. That means we would cancel out 3 sets of x's, and we would be left with 2 in the denominator. So up top, there's nothing left but a 1, and then in the denominator, we get x squared. That means that x to the negative 2 and 1 over x squared are the same thing. So those are equal to each other. What this means in terms of a rule is that if you have a negative exponent, you just throw it into the denominator and make it positive. So a to the negative m is 1 over a to the positive m. And vice versa. There's like a similar rule that if you have 1 over a to the negative m, this is the same thing as a to the positive m. Next rule, power of a power. If you have two powers stacked like this, the expanded version of this is to have x to the 6th times itself, which you could expand all those, but we already have the rule of if you're multiplying two things with the same base, that you add their exponents. So this is x to the 6th plus 6, which is x to the 12th. Now, instead of adding together, however many times you're multiplying the power, you can really just look at the power of a power here and notice that 6 times 2 is 12. So if you have power of a power, you multiply. This is a to the mn, where m and n are multiplied with each other. Let's do a couple of examples. First up, if I'm going to do 3x squared times 5x to the 4th, this is really just 3x squared times 5x to the 4th. We don't need all those parentheses. And then each of these things are being multiplied with each other. Now, multiplication is commutative, which means I can do it in any order that I want. So I'm going to do 3 times 5 times x squared times x to the 4th, which is 15x to the 6th. Notice that with the x powers, I just added the 2 together. Because they were multiplying with the same base, you add the 2 and the 4 together to get 6. Now for the next example, there's a few different things going on. It's really like 3 separate problems. It's like 12 divided by 2, a to the 7th divided by a cubed, and c squared divided by c to the 5th. So you can think of it like this. 12 over 2 times a to the 7 minus 3, because when you're dividing two things with the same base, you subtract their exponents, and then this will be c to the 2 take away 5. Now, if I simplify 12 over 2, that's just 6. A to the 7 minus 3 is a to the 4th, and then here, 2 minus 5 gives us a negative 3, so we get c to the negative 3. Now, there's a rule in mathematics that negative exponents are not simplified. So, in final answers, you guys are going to need to take any negative exponent and kick it down to the denominator. So our final answer here is going to be 6a to the 4th all over c cubed. And then that is fully simplified. For this example, because we're cubing it, that means that you would do negative 4pq squared times negative 4pq squared times negative 4pq squared. Now, you don't always have to expand them all the way out like this. Eventually, you can sort of see the pattern that if you were to expand it, you would have 3 sets of negative 4s, which means that we get negative 4 cubed. Then, if you have 3 p's, that means we get p times p times p, which is p cubed. And then, if you have q squared times q squared times q squared, you get q squared to the 3rd. Now, negative 4 to the 3rd is negative 4 times negative 4 times negative 4, which I think is negative 64. Let me check that. 4 to the 3rd power. Yeah, 64. So you get negative 64 out front. The p cubed is just p cubed, but then power of a power, you multiply their powers. So you get q to the 6th. And then that is it. Another rule that we should go over is fractional exponents. So if I were to start here with x to the 1/2 times x to the 1/2, our addition or our multiplication rule says that we need to add those 1/2s together, which is the same thing as x to the 1, which is the same thing as x. Now, you guys, we also know that if you have the square root of x times the square root of x, that this is the square root of x squared, and then the square and the square root cancel each other out, so you get x to the 1 power, which is just x. What this means is that the square root of x has to be equal to x to the 1/2, because it's like something times itself that equals x, something times itself that equals x. So the somethings must be equivalent to each other. So these two must be the same thing. What this means is that anytime you have a fractional exponent, that this can be rewritten as the nth root of a to the m. Notice that here, there's a little ghosty 2 that we don't write in the cradle in the index of the radical. So that 2 right here is the same as this 2. So your denominator is the same as the cradle. Now the m can either be inside the radical, like I've written it here, or an alternative way to write this is that you have the nth root of a all to the m power. So those are all equivalent to each other. Next example, write x to the 3/2 in a form involving a radical term. So if it's to involve a radical term, that means we need to take the fractional exponent and turn it into a radical. Remember that this is your root that goes in the cradle. So that means we do the square root of x to the 3rd, but you don't really need to write a 2 when it comes to square roots. It's just implied if you leave it like this. So here, you can write your answer as the square root of x cubed, or another way to write this is that you could have the square root of x all to the 3rd power, or an equivalent version that I'm not sure if your book cares about. Let me see. No, they don't care. Okay, so we'll just leave it there. Next example, without using a GDC, so don't grab your calculator, we're going to simplify 8 to the 2/3. Well, one thing you need to recognize is something I call hot numbers. So, let me see. Some squares that you guys should recognize are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 12 would be 144, then I think it's 169, and then after that I really lose track. So those are all perfect squares. Like each of these are 2 squared, 3 squared, 4 squared, 5 squared, etc. But in addition to squares, we should also know some cube numbers, so some perfect cubes. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And then honestly, after that, I don't remember them. They don't seem to come up that much. To the 4th power, so 2 times 2 times 2 times 2 would be 16. 3 times 3 times 3 times 3 would be 81. And then after that, I kind of trail off. I don't really recognize them. So, you guys, this number right here, this 8, is a hot number. It's this hot number right here. It's a perfect cube. So, what we can do is rewrite the problem. So, 8 to the 2/3 is the same thing as 2 cubed to the 2/3. Then you have power of a power. So this becomes 2 to the 3 times 2/3, which is the same thing as 2 squared because the 3's cancel each other out, which means the answer is 4. So look for those hot numbers. If you see a hot number like one of, any of these guys, you should always think, oh, I can rewrite one of the numbers as a power, as a base with a power. I'm gonna let you guys go ahead and try this one. Try rewriting the 27 as a power. Next example, we're going to solve this. This is similar to that last problem where you should have kind of an alarm bell that goes off here that 27 is a hot number. It means it can be rewritten as 3 cubed. It's a perfect power. So we get 3 to the x plus 2 is equal to 3 to the 3. Now, if you have the same base on both sides, you can go ahead and get rid of that base and just set the exponents equal to each other. So we get x plus 2 is equal to 3. So x is equal to 1. Go ahead and try this one. It's slightly more complicated because you actually have to rewrite both sides. All right, you guys, there's your answer. Okay, you guys, that is all I have for us today. Please dig into the homework. There's a lot of problems in there.